Hello children. Today we're going to learn coordinate geometry. The first topic in your coordinate geometry is gradient of a line. And the gradient of the line you have already done, that the gradient of the line is given by m is equal to y2 minus y1 upon x2 minus x1, right? So that is, it is change in y to change in x. What does the gradient basically tells me? The gradient is the inclination of the line, right, with respect to the positive direction of the x-axis. So you can call it slope, you can call it gradient. It tells me the inclination of the line. Okay. Now on the right side, you can see I have a line and it's joining 2 points. 3, 1, that's the point A, and the second point joining the line. It can be any point on the line. I have just marked 2 points. So is B is 1 comma. So now how do you find out the gradient? So first I just label one point as x1 and y1 and the second point as x2 and y2. So while labeling, just remember, if you're taking x coordinate of a point as x1, then the corresponding y coordinate should be y1, and same is with x2 and y2 as well. Okay, so now the gradient is given by your y2, which in this case is 4, minus y1, that is change in y now, 4 minus 1, upon the change in the x, that's x2, which is 1, minus x1, which is 3, right? So it becomes 3 upon minus 2. So the gradient of the given line is minus 3 upon 2 or minus 1.5. Okay, now let's take one more example to this. Like I have this line, I have labeled 2 points here. The point A is labeled as 2 comma 2 and the point B has coordinates 4 comma 4. Let's again find out the gradient here. The gradient again y2 minus y1 upon x2 minus x1. So now my gradient will be, let's take this as x1 and this is y1, this is x2 and this is y2. So the gradient will be y2 minus y1. So in this case 4 minus 2 upon x2 minus x1, again 4 minus 2. So it comes out to be 2 upon 2. So my gradient is 1. So for the given line, the gradient is equal to 1. Right? Okay. Now let's take few more points and try finding out the gradient. Let's take a point A as 3 comma 5 and the point B as 5 comma 5. Let's take it. Okay. Now I'm labeling this as x1 y1, this is x2 y2. Try finding out the gradient again. So that becomes, in this case, y2 is 5 minus y1 again 5 upon x2 is 5, x1 is 3. So what do I observe here? My numerator came out to be 0 and so my gradient as well. Let's just start plotting these points on a grid. If you just try and plot them, where are the points? Now the point A is 3 comma 5. So I'm just marking 3 here and 5 somewhere here. So this is your point A, which is 3 comma 5. The point B is 5 comma 5. So let's have 5 here and this is the corresponding 5 on the y-axis. So this is my B point. Now what do you observe here? If you join this with points, you will find that I get a line which is parallel to x-axis, right? It's a line which is a horizontal line, or we also call it a horizontal line, right? It's a line parallel to x-axis or a horizontal line. And what do I observe about this line? I observe that my gradient is 0 for this line, right? So that means every horizontal line, that is every line which is parallel to x-axis, will have same y coordinate and the gradient of that line is going to be equal to 0, right? Let's take one more example now. Now this time I'm taking A as 3 comma 5 and the point B as, let's take it 3 comma 3 now. Let's again label x1, x2, y2. So my gradient comes out to be y2 minus y1, which is 3 minus 5, and x2 minus x1, that is 3 minus 3. What do I observe here? My numerator is minus 2, but my denominator has come out to be 0. So if I can't do that, right? I can't have a denominator to be 0. If my denominator is 0, we call that to be a not defined, right? It's not defined only. Let's again plot them on the grid. What do I observe when I plot them? So if this is your 3 and this is your 5, that's my point A. And if this is 3 here and this is 3 and that's my point B. Now when I join them with a straight line, what do I get? I get a line which is parallel to y-axis, or I get a line which is a vertical line, right? This is called a vertical line. And what do I observe? My gradient is not defined. Why here? Because my inclination to the x-axis here is 90 degrees. It's a perpendicular line and my inclination is 90 degrees. Okay, so that means any line which is parallel to y-axis or which is a vertical line has a gradient which is not defined, right? Not defined. So which has a gradient which is not defined. Okay. Okay. Next, what do we have? So that's all about gradient, how you find the gradient. Then what about the gradients for the line parallel to x-axis? That's 0. Gradient of the line parallel to the y-axis not defined, right? Now the next topic in line and the coordinate geometry is the important one, which is the equation of the line. We've been doing so many equations which we were been calling linear equations. Remember, while solving in algebra also, why do we call them linear? We call them linear because if you draw them on the graph, you will get a line. So the general equation is y is equal to mx plus c. General equation of the line is y equal to mx plus c, where your m is the gradient and the constant c is your y-intercept. Now what is this y-intercept? Y-intercept is, let's say if I draw a line like this, right? So the point where the line cuts the y-axis is your y-intercept C. That means y-intercept is a point where your x is equal to 0 or where the line cuts the y-axis, right? Where the line cuts the y-axis. Now, the second point is, how do you find the equation of the line? Now, for finding the equation of the line, I need to know two things, right? The first thing is the gradient of the line, right? First thing I should know is the gradient of the line. The second thing which I need to know for finding the equation of the line is the point through which the line passes. Any one point, line passes through infinite points. I should know only one point through which the line passes. If I know these two things, I can find the equation of any line that's possible, right? Let's take few examples and try to find out the equation of the line, right? Now the first example, which is a simpler one, that's one option which you can get. They give you a point through which the line passes and they give you the value of the gradient and they'll ask you find the equation of the line, right? So we've discussed that the equation of the line is y equal to mx plus c. They already gave me the value for m, right? They gave me the value for m and the value given to me is -2. So what do? I just substitute the value of m here, which is given to me. I'll substitute that value as -2x plus c. What I don't have the value of c. How will I find out? I will use this point for finding out that value, right? So the point coordinates is 5, comma 3, and it says that the line passes through this point. So that means I can put my x as the x coordinate here, which is 5, and my y as y coordinate here, which is 3 in the given equation. Plug in the values of x and y now. For y, you're going to put as 3 equal to -2. For x, you're going to put as 5 plus c. So that becomes 3 equal to -10 plus c. So 10 goes in here. C becomes 3 plus 10, and so the value of the constant c comes out. That is, your y-intercept comes out to be 13. Now what do I have? I have the gradient. I have the y-intercept c, right? What I need to do is, I'm just going to put the values here in the general form. Y is equal to mx plus c. Just put in the values. Y equal to, instead of m, put -2. X as it is, plus, instead of c, put 13. There you get your equation of the line. So this is the equation of your line, right? Okay, next we have one more type which can be given. Now this time they're not giving you gradient. They're going to give you the 2 points through which the line passes, right? You have 2 points through which the line passes, and they're asking you find the equation of the line. Now I told you earlier, I need 2 things to find the equation of the line. What are those 2 things? One thing is the gradient and the second thing is the point, right? Point I have. I have 2 points. I can use any of the 2 to find the equation. What I don't have is the value of m. So my first step is going to be finding the value of m, which you know is given by change in y upon change in x. I have 2 coordinates given. Label them x1, y1, x2, y2 is the second one. Put in the values. Your y2 is 5, minus y1 is 2, x2 is 3, x1 is 5. 5 minus 2 becomes 3, 3 minus 5 becomes -2. So my gradient is -3 by 2. Now y is equal to mx plus c. Put the value of gradient here. You got the value, that's -3 by 2 x plus c. Now I have 2 points. So I can use either of the 2 to find out the equation. Your value, your equation is going to be same whatever point you've been using, because both are lying on the line, right? So I'm using the point A for the time being. So A is 5, comma 2. I'll put the values in this equation. Your y is 2, so put in 2, equal to -3 by 2. Your x has a value 5, put that value 5, plus 6. So you get 2 plus 15 upon 2 equals c. That gives me the value of c as 19 upon 2. Now you got the value of m, you got the value of c, put it in the general form. Y is equal to mx plus c. That becomes y is equal to -3 by 2x plus 19 by 2. So this is the equation of the required line, right? Okay. So let's take one more example for finding the line equation. It says find the equation of the line passing through the points 5, 2 and 7, 2. Even before finding this, can you see something common in both the points? Yes, what we can see is the y coordinate for both the points is actually same, right? That means if these are the points, y coordinate same being y is 2 only, x is 5 and x is 7. So these are the 2 points, right? So when I draw it, I'll find that the equation of the line is going to be the parallel to the x-axis, right? With a constant value of y being equal to 2 all over the line, right? So the equation of this line can be written as simply y equal to 2 because the gradient is 0 and the y-intercept is 2. So any equation of the form which is any equation, any line which is parallel to x-axis is actually equal to the form y is equal to b, right? It is equal to the form y equal to b, right? So the equation of any line which is parallel to x-axis has an equation of the type y equal to b, where b is your y-intercept, right? So in this case, it is 2, so the my equation is y equal to 2. Let's take one more example. Now it says find the equation of the line through these 2 points. So what is common in these 2 points now? Yes. Now my x coordinate is same, right? If my x coordinate is same means it remains 5 and this is 2 and this is 7 on the y. So these are the points, right? So that means now my line is parallel to y-axis, right? And no matter what, every time what is my x has a value on the line, x has a value 5 every time on the line, right? So the equation of this form becomes x equal to 5 because now my gradient is not defined and the x-intercept is 5. So any line which has equation which is parallel to y-axis is of the form x equal to a, where your a is the place where it intersects the x-axis, or we also call that as x-intercept, right? So that's why it is intersecting the x-axis at 5 here, and we call that equation of the line as x equal to 5, right? We'll discuss the parallel lines and perpendicular lines in the next video. Till then, bye-bye.